Now we're starting the second part of the unit on networks. And here we're going to shift a little bit from our graph theory, but we're still going to use the idea of trees to help organize different tasks that need to be done. So let's take a look at an example and see where things are headed, and then we'll hop into notes. So in this exploration, we have two workers of the tractor building business. Their names are Michael and Kyle, and they wish to streamline the process of building the tractor for their business. Each of the 10 tasks involved in building the tractor must be completed by only one person, and the names of each of the tasks is so complex we have simplified them to T1, T2, and so forth on to T10. Since the order in which some of the tasks matters, the table below shows the prerequisite tasks along with the times to complete each task. So we have our task list here in numeric order. We have the amount of time it takes to complete the task, and then we also have what we call the prerequisite tasks. That means that before we can get one of those tasks done, something else has to be completed. So for example, in order to move on to task 2, you need to make sure that task 1 is completed. This would be very common in manufacturing if a certain part has to be assembled prior to being added to another part of the assembly line. All right, let's take a look at the first question. What is the least time it would take Mike to finish a single tractor working on his own? I want you to pause the video for a minute and take a look at this table and see if you can figure out how we would know how much it would take Mike to go ahead and complete this. Okay, so now you've had a chance to think about it. Hopefully you took a look and said, okay, well, if I take all the times here and I add them up, so 4 plus 1 plus 4 plus 2 plus 4 plus 1 plus 1 plus 2 plus 2, I would see that it will take 22 hours for Mike to put it together. That does not even include bathroom breaks or lunch breaks or anything else, right? So for 22 hours, he could get that completed. All right, let's take a look at number 2. What is the least time it would take Mike and Kyle to complete a single tractor? Explain your answer and write or display a schedule for Mike and Kyle that shows what task each is doing and in which order. Okay, so what I need to do is actually grab this table. So I'm going to go ahead real quick and snag a picture of this. And then I'm going to pull it. Okay, save it. And then I'm going to go ahead and pull it right down here so I have it handy and ready to go. So I'm going to pull that table a little bit smaller and put it right up there. All right, so I've got to come up with a system to be able to figure out how to assign stuff. And I think what I'm going to do is I'm just going to go ahead and make a chart, because that might be the easiest way to look at this. Okay, all right. So I have 2 people, Mike and Kyle, so I'm going to make a chart for both. And then what I'm going to do is go ahead and block these off in 1 hour increments. So 1, 2, 3, 4, 5, 6, 7. Okay, go ahead and fast forward through this process. All right, so each of these increments is 1 hour because I want to kind of see what we can do. So I'll start with that, and I'll put Mike on one and I'll put Kyle on the other, and it doesn't really matter which one goes first. Okay, so first thing I'm going to do is I notice that in order for task 2 to be completed, I have to finish task 1. So I'm going to go ahead and grab task 1 first. So task 1 is going to be 4 hours. So I'm going to go ahead and fill in 4 hours, and then I'm going to go ahead and call it task 1. Okay, is going to be this amount of time. So after I finish that though, then I can go ahead and get into task 2. And task 2 only takes 1 hour. So I'm going to go ahead and map out task 2 and get that labeled. So T2. All right. So I can't get T2 done until I get T1 done. So I went ahead and put that in. Now let's go ahead and take a look at what our next prerequisites are. I don't need anything in order to be able to do T3 or T4 or T5. So those are things that need to be completed. Let's do T3 is needed in both of these and also in this one. So let's go ahead and do T3 next. So I'm going to go ahead and have Kyle jump in on T3, and T3 is actually a 4-hour job. So I'm going to go ahead and put T3 right here, and that's going to be T3. Okay. So now I'm up to 4 hours, right? Because this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, okay? All right, so T2 is not done. So I can't do T6 and I can't do T7, but I also have to get T4 done. So what I'm going to do is have this guy here go ahead and tackle T4. So T4 is going to be next. So that's going to take 2 hours. Okay, T4. And I'll go ahead and label that T4. So now we have T1, T2, T3, and T4. And we've only gone 6 hours, right? Mike's been working 5 hours and Kyle's been working 6 hours. And that alone would have already taken 11 hours on our old system of what Mike was doing. Okay, so Mike finishes before Kyle is done. So I'm going to go ahead and put Mike on that T5. So we'll put Mike, let's see here. We'll put him on T5, and T5 is 4 hours. So 1, 2, 3, 4. We'll put him in there. Okay. So that takes, and the idea is that you want someone to be working on something at all times, right? So T5. All right, so that T5 is going to take some time. Now I can look at what can Kyle be working on until that T5 is done. And if we take a look at T6, it does not require T5 to be completed, only 2, 3, and 4. And that will take an hour. So I'm going to go ahead and do an hour. And that's going to be T6. So T6 is done. And then T7 is also 1 hour. So I can go ahead and get T7 done as well. So I'm going to go ahead and put T7 in there. Okay. So T7 is done. Okay. T8 and 9 cannot be done until T5 is completed. So what's going to happen is poor Kyle is going to take a lunch break. Okay. So there's nothing he can do at that point because everything else that's left requires 5 to be done. Now, you might say, well, T10 doesn't require 5. Well, but it requires T8 and T9, which need to include 5. So once 5 is completed, then we can actually venture into T8. So I'm going to go ahead and have Mike work on T8, and T8 is 1 hour. Okay, so that's T8. And then what can Kyle be working on? Kyle can do T9. So T9 would go to Kyle. So 2 hours. So he's nice and rested. Can work for 2 hours. So T9, that's completed. And then once T9 is done, we can go ahead and get T10 done. And it doesn't really matter if Mike or Kyle do it. Bottom line is T9 has to be completed before it happens. So either, it's a 2-hour window, so we could go either to Kyle or on up to Mike. Either way, okay? So you could have it be one or the other. So we'll call this T10, and then we're done, right? So we're going to put a line at the end of manufacturing, and we are at 13 hours. Okay, so we were able to save 9 hours by adding somebody. So let's take a look at where we are. So Kyle is at 11 hours. And then he also had a break in there. So that was really only 10 hours that he worked. And of course, we had an hour in here that Mike took a break. So there's probably a more efficient way, but 13 hours seems pretty good as far as 2 people working on it. So at this point, I want you to go ahead and I'm going to put this next part in a second video, but I'm going to explain it here. Mike and Kyle decide to hire as many workers of the tractor trade as they need in order to complete a single tractor in the minimum amount of time. So we've got to figure out how quickly it can be done. So the way I'm going to do that is I'm going to try it with 3 workers, and that chart would have 3 people in it. And then I'll try 4 workers, and I'll have a chart with 4 workers in it. And then we'll try 5 workers and see if that's any faster. Okay, so go ahead and work on that, and we'll meet in the next video.